hardest part is to go from infinity down to a small finite number. The rest is really just details. So I think this is widely underrated, excuse me. And so it's impressive, and it makes you wonder, why is it even possible, right? Why does the universe work in this way, where most of the complexity arises from the arrangement of simple things, right? It's like we live in a universe designed by the Lego company, right? I mean, that's their idea, right? With a few basic building blocks, you can make anything. You can make dinosaurs, you can make pirates, right? You can make dinosaur pirates, right? Anything you can make with Legos, which is why they're wonderful. But why is our universe organized by the Lego principle, right? Why does most of the complexity arise from the arrangement of simple objects, not the objects themselves? We have no idea, but I'm glad that we do, because it makes particle physics possible, right? And it could have been different. If you were a caveman or cavewoman physicist, you have to consider all the new ideas about how the universe might work, right? And one of them could have been that everything in the universe, all the different stuff, could have had its own different little particle, right? It could be, for example, that cats are made out of their own little cat particles, and that's why they're so weird, right? And everything, you know, cartoonists and Batman and spaceships and everything could have been made out of its own different particles. That could have been our universe. It isn't, fortunately, but we don't know why, right? That in our universe, most of the complexity arises from the arrangement of stuff, not from the stuff itself, which to me is fascinating. All right, but so we have the periodic table of the elements, right? That's where we stand about 150 years ago. But we don't just stop there and say we're done. There's a list of our knowledge, right? We don't make lists because they're not insightful, right? We organize them because there's a lot of interesting patterns in the periodic table, right? And so, for example, it is periodic, right? And some things over here are very active and some things over there are very inactive. And we notice these patterns. These patterns, of course, lead to questions like, why does this happen? Why are the adjacent atoms similar to each other? Why does the position in the periodic table tend to predict things like the metallicity and the conductivity and the activity of it, right? You can tell when Jorge gets bored because he starts playing Tetris on the screen. Anyway, so we look at the periodic table and we notice, right? We notice these patterns. And of course we know now that all the structure in the periodic table is not random. It's a clue. It's a clue that points us directly to the structure of the atom, right? It tells us everything, the structure of the atom and how the protons and the neutrons fit together and the electrons whiz around it. All of those things determine all the structure in the periodic table. So I don't tell you this because I think you don't know. I'm sure you do, but I want to make the point that this approach works. Looking at patterns, asking questions, and then using those questions as a guide will help you reveal the layer of reality that's underneath. And in the end, that's how we want to answer this question, right? And fundamentally, there are no hula hoops at the lowest level of the universe, but you know, maybe we'll find them, we'll see. All right, but in the end, our goal is to explain the universe at its most fundamental level. And you might be wondering, what is that, right? Well, it's not the atom, right? And in fact, nothing that you see around you is the most basic building block of the universe, right? Nothing in your macroscopic world, right? Not atoms, certainly, not llamas, right? Not tornadoes, not even like llama tornadoes, right? Or crazy other things like that. So nothing that you're familiar with, llama-nados, right, nice. We're actually pitching a show to Sci-Fi Channel about llama tornadoes next week. I hope that's Brad Pitt running away from the tornado. No, I wish him nothing but well. And let's drill a little deeper into the structure of the atom, right? Because we know the atom is not the most fundamental unit, but the atom has electrons around it, and in the nucleus there's protons and neutrons, right? Inside the protons and neutrons are other little particles we call quarks. So we have the up quark and the down quark, two up quarks and a down, or two down quarks and an up, and you have the proton and neutron, right? Which is amazing because it tells you that even at the level of the proton and neutron, this works, that the complexity there, the particles we see, are just made of smaller particles and their arrangements. The arrangements of the quarks is what makes it a proton or a neutron. And something else that's astounding is that it means with just 3 particles, up quarks, down quarks, and electrons, you can make any atom. And of course, with any atom, you can make anything that you've ever experienced or eaten, right, or tripped over. That's incredible, right? I mean, if you asked a particle physicist to write a cookbook, for example, there would be only 3 ingredients in every single recipe, right? And of course, the hard work is in the arrangement, right? So, yeah. That's the way it would work. I'd still having trouble selling that to publishers. And so you might be thinking, wow, these guys are almost done, right? We're explaining the universe. We have infinite complexity, overwhelming. Boil it down to 100. Okay, that's pretty good. Now we're down to 3 particles, right? You might think, well, if I'd been here next week, we'd tell you about the one particle that rules them all, right? It seems like the answer is almost around the corner. Well, it's not. And the reason is that there's some wrinkles to this story. And one of the wrinkles is that there aren't just these 3 particles. So we have the up quark, the down quark, and the electron, but for example, there are other quarks as well. So you see the Cham quark, the strange quark, the top quark, and the bottom quark. Okay, now I was not on the committee to name these particles, so I take no responsibility for that. The electron also is a member of a group of particles we call leptons, and there's 6 of those as well, right? So we were on track to explain everything in the universe in terms of just 3 particles, which seems great. Now we have 12, right? Oh no, what do we do? Well, we don't just make a list, right? Lists are not insightful. Instead, we organize our knowledge and we look for patterns, because those patterns are going to be the clues to questions that lead us to the next deeper layer of reality, right? So now we have a new periodic table, but now it's a periodic table of the fundamental particles instead of a periodic table of the elements. And the amazing thing is that there's a lot of patterns in this table. So let's take a little tour. Here you have the up quark, the down quark, and the electron, right? These are the stuff that makes up me and you and Jorge and hamsters and all the good stuff, including planets and stars. In this first column, we also include